let's have a look at this question. Now, before I rub this off, let me make a couple of cautions. This result here, thankfully for you, to be honest, is not to be memorized. Not to be memorized. That's a good thing because you look at that and you think, how am I supposed to memorize that? It's not to be memorized, number one, because it's awful, but number two, because you have to show where it comes from. Okay, we only look at it in these terms to show you that when you put these together, you do indeed get a parabola. That's the point, that's all. But you can't use it, okay? And that's actually a good thing for another reason, which is that usually you don't have it in all of these really vague terms, okay? Usually you actually have numbers in there, as you do in this case, which makes it a lot easier to actually compute all of these bits and pieces, okay? So let's have a go at this. Part A, okay? Oh, now, by the way, before I go on, when you have a look at the question, just read some of the questions with me, right? Find horizontal range. Find greatest height. Show that the ball's 9 meters above the road, etc., right? All of those questions that I just read to you have nothing to do with time, right? So even though here they're sort of guiding you along and saying, use the equation of path, use the equation of path, those are the kinds of signals to you to say, oh, okay, this is going to be a superior approach to this, okay, because I'm more interested in x and y's. It's only at the very end when you have a look at the time of flight where you have to appeal back to your time equations, okay? But for the rest of them, the equation of path is much more elegant, okay? So, first what we want to do is get our displacement equations for x and y. So where I'm going to begin is with this guy. Okay, I'm going to need to resolve the initial velocity and then I can use those to evaluate all my constants out. Okay, so I think you've got this, 20 meters per second, yeah. The alpha they give you here is tan inverse of 4 on 3. Tan inverse of 4 on 3. So the ratio you've got here is 4 to 3. 4 to 3, okay? Except this side is not 4 and this side is not 3 because it doesn't fit Pythagoras, does it? 4 to 3 is just the ratio, not the actual lengths. So to preserve the ratio, 4 to 3, but to get the right hypotenuse, what are these values going to be? 12 and 16, right? Here's my x dot, my initial x dot, I should say. And here is my initial y dot. Okay, great. I'm going to use those in a second. Let's begin. Horizontal acceleration. Every projectile motion question. Always 0. Cool. Now, I'm going to do this in the short form because I think you've got the right working there, but you've got to do all of the constants and integrate and so on. But you're going to get to this. You get a constant, and the constant must be this, right? You sub in the initial velocity, so you get that, okay? Integrate again to get to displacement. And because you're starting at the origin, the constant that flies along here is 0, no problem, okay? Now you deal with your vertical dimension, okay? They're a bit naughty and they don't tell you what you should define gravity to be. But looking at the question of what they've assumed, what they want you to prove, what can you assume gravity to be? Negative 10, good. Because you're going to get that negative 5t squared out at the end, okay? So if I integrate once, okay, that'll become negative 10, minus 10t, okay? But then you sub in your initial condition, right? So you get that. Integrate one more time to get to your vertical displacement, and this will be negative 5t squared plus 16t. You'll have another constant here, but I'm starting at the origin, so this constant will be 0. There you go. Well, I mean, you flip them around, that's it. That's kind of why I was surprised that it was taking so long to get these equations. They don't take long. You always start from these two every time, every projectile motion equation, projectile motion question, and these will fall out, okay? Now, they don't tell you to do so, but the point of this is to say, well, okay, if I put these together, what will I get when I eliminate the parameter? Okay, so let's do it. Probably easiest if I rearrange that. Make t the subject, so you get this. Okay, so when I slap this into my y equation, here's what I've got. Minus 5. There you go. Okay. I could tidy it up a little bit, but as it turns out later, there's not much point in doing it because I'm going to be multiplying through all of this to get rid of the awkward fractions and then solve this thing. Okay. So there you go. There's my equation of path. What's part B asking for? We want number 1, horizontal range, and number 2, greatest height. Okay. So horizontal range is how far am I going to go over there, right? In xy terms, in Cartesian terms, that's just the root of this equation that's not 0. That's all. The root of this equation that's not 0. Okay, so we can do that. It's easy. You can say, to find range, or horizontal range, I should say. And this is actually the way that I would set it out, right? Try as much as you can to avoid equations just, popping up out of nowhere without any explanation as to why. Okay, let y equal 0. That's going to tell me how far I go. Okay, so there's my equation. Okay, what ought I to multiply by to get rid of all of these awful fractions? Probably 144. I'm thinking 144. That'll get rid of this guy. It'll get rid of this guy and then some, but that's okay. All right. So this will become minus 5x squared. 16 times 12. 12 times 12 is 144, and it's an extra 48. So I think it's 192. Yeah. Okay. There you go. So I want to solve this. You can clearly see that one of the solutions is x equals 0, naturally, but I want the other one, don't I? Okay. So I'll just factor out. Let's see, I'll factor out an x, which will give me this. 192 minus 5x. So here are my two solutions. Okay, what's that? 192 and 5. That's they didn't give it to us, do they? What is it? Decimal? Anyone? It's close to 40, isn't it? Just a bit under 40? 38.4 meters. There you go. There's the horizontal range. Ta-da! Now the next thing they want to ask for is greatest height. Greatest height. Now, some of you have gone to y dot equals 0. Y dot equals 0. Okay? And then you've gone back to time. Well, you can get the answer that way. But the point of doing this is that you don't need to. You don't need to. You know that the greatest height will line up exactly halfway between where you start and where you finish. Because it's a parabola. It has this axis of symmetry. Okay? So all you need to do is say, there's no extra part. You just say when x is equal to, and you just halve it. You don't need to provide any argument for that. Okay? And you can sub that into your equation of path, right there. Okay? So you're going to get this. Okay? All you have to do is crunch the number, and I think we should get 12.8. Is that what you get? Ta-da! See how simple that was? Don't go back to time, get a time value, then put that into y. What a waste of time. Okay? Just go straight there, right?